Hey everyone, this is going to be question number 6 on discussion number 3. And so I don't know if you can hear the beeping in the background, fire alarm is going off for some reason, but hopefully you can still hear me through all of this. But yeah, let's get started. And so talked about this a little bit in discussion, so I won't go over it too much, but basically we have like two numbers, n1 and n2. Let's say we have like 31, 42, and we want to turn it into 4, 3, 2, 1. So we're merging them together. And we want the final result to be in decreasing order. And so the thing to note about n1 and n2 is that their digits are already in decreasing order. And so I guess like a couple hints, if you haven't started this discussion problem yet, is that, right here it says, I don't even need to think about what to say. If you can figure out which number has the smallest digit, then we know that the resulting number will have that smallest digit followed by the merge of the two numbers with the smallest digit removed. And so, yeah, it kind of like discusses the recursive call, and so we can talk about that. And so the question is, we kind of want this 1. We want to find the 1 out of 3142, the smallest digit. And the thing is, how do we find that? Well, what do we know about n1 and n2? Where is their smallest digit? Well, we know that the digits are decreasing in n1 and n2. So that means that their smallest digit has to be on the right. So 1 and 2. And what does that tell you about the smallest digit in like 4321? Well, the smallest digit in 4321 has to be either 1 or 2. So if you can find which one it is, then we can take that 1 out, and then we can merge 3 and 42 in to get 432. And what we can do here is we can essentially take that 1 we just took out and then throw it back in to get 4321. And so that's going to be what our recursive call. That's going to be our recursive call. And so how do we compare the 1 and the 2 and find out which one is smaller? Well, we want to use the modulo operator. So remember n mod 10, if n was 31 or something, then n mod 10 would get us 1 out of it, and say with 42 it would get us 2 out of it. And we can compare the 1 and the 2, and we see that 1 is smaller, so 1 is the digit that we want to be taking out of 31, and it becomes 3 and 42, and we get 42. We put in that 1 back in. And on the other hand, it feels like 53, like 42. Now we know that the smallest digit is the 2. I'm just going to reset the board. We have like 53, 42. We see that 2 is the smallest digit. So essentially, we're going to take that out, and we're going to merge 53 and 4 together. And, you can use the recursive leap of faith, kind of assume that, 53, merging 53 and 4 together gets us 5, 4, 3. And then we can take that 2, throw it back in, and we get 5, 4, 3, 2. And so that's going to be our recursive call. And so next up, we want to think about the base case. And so, we have like 5, 3, 2, maybe 4, 2, 1, 4, 2, 0 or something. We first remove this 0 for now. And, we remove the 2. That's another recursive call. We can remove either 2. Doesn't really matter because it's the smallest digit. But then we're going to remove that other 2. And, each of these removals is leading to another recursive call. So just keep that in mind. We're going to move this 3. We're going to take out this 4, and look over here. We have 5 and 0 now. And so the thing to note about this 0 is that 0 does not count as having any digits. And what happens when we try to merge some number with some number that doesn't have any digits? Well, we're just going to take the digits from that 5 over here. So merging 5 with 0 is going to become 5. And similarly, if I merge like 5, 4, 3, 2, 1, and 0 together, no digits on this side, so we can just take n1 as it is. And so that's going to be one of our base cases. If n2 is 0, then we can just return n1, because there are no digits from n2 to merge in. However, the same applies the other way. And so note that we can be taking digits from both sides. So let's say this was like 2, 4, and 32. So we're going to take the 2 out. That's a recursive call. We're going to take the 3 out. That's a recursive call. that's a stupid example. So let's say it's 32 and 4, the other way around. So we're taking digits from n1, and n1 becomes 0. And so if n1 is 0, then we want to return n2. So since we're taking digits from both sides, one of them can hit 0 for either n1 or n2 can hit 0. So we need to account for both cases. And so yeah, keeping that in mind, let's get started. And so remember, we just talked about our base case, so let's code that up. So if n1 is equal to 0, then what do we want to do? Well, we want to return n2 in that case, because there are no digits from n2 that we can really use. I mean, there are no digits from n1 to merge in, and so we just have n2. Likewise, if n2 is equal to 0, then we're going to return n1. Now here comes the recursive call. And so remember that, I'll bring back this example. We have 31, 42. We're trying to find the smallest digit of n1 and n2, because those are the smallest digits, and if we find the smallest digit out of both of them, that's the smallest digit of like the entire number that we're merging in. And we can take that out, make the recursive calls, and get our solution. And so what we're going to do here is we're going to check if n1 mod 10 is less than n2 mod 10. So if the first digit of n1, so that means if the digit in n1 is the smallest digit out of everything, then what do we want to do with that? Is we want to take the digit away. So we want to take that 1 away. And how do we do that? We do n1 floor div 10. And n2 is going to stay the same. It's going to stay 42. Or like n2. And what do we want to do with this? We want to merge these together. Merge n1 divided by 10, so the 3, and n2 the 42. And then we can assume that we're going to get 432 out of it. And then what do we want to do here? Well, we want to insert that 1 back into the 1's digit. And so how we're going to do this is that we're going to take this 432, add a 0 to it, and then add 1 back in, and we get 4321. And so we're going to do this by multiplying it by 432 by 10. So if we take the result of merge, multiply it by 10, and add that digit that we just took out back in, we're essentially inserting a digit at the very end of our sequence. So we're taking the 1, that's n1 mod 10, and we're inserting it into 432, which is the result of the merge call. And then what do we want to do with that? We want to return it. And otherwise, we want to do the opposite way. So in this case, we're taking a digit out of n2. So n1 is going to stay the same. n2 is going to we're going to take a digit off, and we're going to multiply it by 10 and insert that digit back in. And yeah, so this is going to be merge. And yeah, so one thing to note is that you could have like less than or equal to, less than. Doesn't really matter, because if you had like 32, 42, doesn't really matter if you take out like the 2 from here over the 42 from here. So if I took out the 2 from the 42, then it would become 42, and then we'll add that 2 back in. Likewise, if I took it from the 3, then it'd be 3 and 42, merge these together, we got 432, add the 2 back in, it's going to be the same thing. So it doesn't really matter if you have a greater than equal to, less than equal to, or less than. But yeah, and if we were to run this, hopefully it works. Hopefully I didn't mess up. Go. Alt. Wait, what the hell? Okay, I think I just clicked it twice. But yeah, so this is going to be the merge. This is the solution to merge. And once again, let me know if you have any questions about this. And I hope you have a great rest of your day.